In this video lesson, we're going to learn about alcohols and ethers. So alcohols have a functional group of OH, which is the hydroxyl group, and alcohols are liquid at room temperature, and they're soluble in water and other polar substances. But as the number of carbons increase, the solubility of the molecule will decrease. To name an alcohol, you count the number of carbons in the parent chain, and that would be the longest chain that has a hydroxyl group in it. And you name the molecule like an alkane, but you drop the E at the end and add OL. And you need to number the position of the OH group from the end closest to the functional group if necessary. So here's our first example. We have 3 carbons, so 1, 2, 3. So the alkane would be propane, so we drop the E and add OL, so it's propanol. And the hydroxyl group is on the end carbon, not on the middle, so it's going to be 1 propanol. Now when I numbered this chain, I should have numbered from the end closest to the hydroxyl group, which is why I said it was 1, not 3. So these numbers actually should not be here. So it should be 1 propanol, not 3. So we can also classify alcohols as being primary alcohols, secondary alcohols, or tertiary alcohols. So primary alcohols, the hydroxyl is at the end of the chain. So this would be the example here. So 1 propanol, so the hydroxyl is on the first or last carbon. A secondary alcohol, the OH is attached to a carbon that has only 1 H. So this would be 2 propanol. So the hydroxyl is on the second carbon. So on that carbon, there's the hydroxyl and then a hydrogen. So just 1 hydrogen. A tertiary alcohol, the hydroxyl is attached to a carbon that doesn't have any hydrogen. So in this example, we have 2-methyl, 2-propanol. So there are no hydrogens here. And that's going to come to be important to pay attention to when we look at some of the reactions of alcohols a little bit later in this video. So now we'll practice with a few. So for this one, we can see the hydroxyl is closer to the left end. So it's 1, 2, 3, 4, 5, 6. So it's going to be hexanol. And the hydroxyl is on the third carbon, so it's 3-hexanol. Our second one, we have the hydroxyl is at the other end. So there's 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be octanol. And the hydroxyl is on the first, so it's 1 octanol. Next one, we're being asked to draw 2-hexanol. So we're going to draw our parent chain, CH3, and we know that the hydroxyl is on this one, so we're going to put COH, and there'll be another H down here, and then CH2, CH2, that's 1, 2, 3, 4 so far, CH2, CH3, and then 1 for butanol, so 1 butanol, so it's going to be, I'm going to draw the hydroxyl at the other end, so CH3, CH2, CH2, and then sometimes we do the CH2OH, like so. So alcohol, as we've learned before, can be formed through addition reactions of alkenes in the presence of a strong acid. So if we had ethene and water, so under steam conditions, in the presence of sulfuric acid, you can make ethanol from ethene. So one of the hydrogens will add to one of the carbons, and then the hydroxyl will add to the second carbon, where that double bond has opened up. Just like hydrocarbons, alcohols can be burned in oxygen, so they can undergo combustion reactions, and they make carbon dioxide and water. And they can undergo incomplete combustion too, which means that they will produce the byproducts carbon monoxide and carbon. So we want to avoid that. So if you take a look here, we have 2 methanol reacting with oxygen during complete combustion to make carbon dioxide and water. And the heat of combustion is negative 726 kilojoules per mole. If you were to burn ethanol in oxygen under complete combustion conditions, you would actually get almost double the amount of heat released. So alcohols can undergo oxidation as long as they have the right oxidizing agent present. So for instance, ethanol in wine will oxidize to acetic acid if it's exposed to air. And acetic acid is vinegar. So sometimes if a bottle of wine is left open or it's not sealed properly, when you go to drink the wine, it tastes and smells like vinegar because it's oxidized. Some good oxidizers to be used in the lab would be acidified potassium dichromate, and that will change from an orange to green to demonstrate that oxidation has happened. Or potassium permanganate will change from purple to colorless to prove that oxidation has occurred. So primary alcohols can undergo both partial oxidation and complete oxidation. Because primary alcohols have 2 hydrogens attached to the carbon attached to the hydroxyl, they can undergo a reaction with one of those hydrogens to make an aldehyde, right here. And then they can further undergo more oxidation to replace this hydrogen to form a carboxylic acid. So this is ethanal, and this is ethanoic acid, which we'll learn a little bit about more when we study aldehydes and carboxylic acids later in our unit. However, tertiary alcohols can't be oxidized under any conditions because there are no hydrogens to be lost off of the carbon during an oxidation reduction reaction, so we cannot oxidize a tertiary alcohol. Secondary alcohols, because they only have one hydrogen attached to the carbon where the hydroxyl is, can only undergo one type of oxidation and produce one type of product. So this hydrogen can be oxidized, so be removed, and this one as well, to produce a ketone. This would be propanone. Now, ethers have an oxygen bonded between 2 hydrocarbon chains, and they're actually more polar than hydrocarbons but less than alcohols. So if we take a look here, you can see the oxygen bonded in the middle. So to name an ether, you select the prefix for the shorter chain and add oxy to the end, and then you add the name of the longer alkane to the end of the first part. So you would name it exactly like an alkane. So here's our example. So in the shorter chain, which is at the right, there's 2 carbons. So that's going to be F-oxy. And then the second part has 3 carbons, so it's propane. So it's ethoxypropane. So now we'll practice with some ethers. So the first one, there's just 1 carbon on either side of the oxygen. So this is going to be methoxymethane, like so. The next one, there's 1 carbon here and then 1, 2, 3. So this is going to be methoxy again, but propane. The third one, we're asked to draw ethoxyethane. So it's going to be CH3, CH2O, CH2, CH3, like so. The next one we'll draw as the more expanded version, so methoxybutane, so we've got a carbon, an O, and then 1, 2, 3, 4. So you can draw them this way as well, so you fill in the hydrogens, like so. Either way is fine. whichever way you find easier to draw, you can draw them that way.